This video is about measuring the burden voltage of a multimeter. We're going to measure the Fluke 8842A's burden voltage. We've got here the burden voltage is basically the voltage drop that occurs when you put a multimeter in series with your circuit in order to measure the current. What happens internally within the ammeter, or the multimeter in this case, is that there's an internal resistor, and then the voltage drop across that internal resistor is used to determine the current. And so that internal resistor puts a burden on the overall device under test, which might be significant. You might have to be concerned about it, depending on the situation, depending on the voltage, the current, and so forth, and how much voltage your device under test needs. This may or may not be a problem. The interesting thing in the case of the Fluke meter is that, and I guess many bench multimeters that have the ability to measure both the voltage drop as well as the current, depending on how the leads are plugged into the device. In the case of the Fluke, what we have here is I've got the power supply feeding voltage into a 10 ohm 50 watt resistor, and then the current flows into the meter down here, and then it returns to the power supply. So we're flowing through the Fluke meter, and the other thing we can do is tie the input from the current input into the Fluke into the high input, so that we can measure the voltage drop internally. The burden voltage directly can be read off the Fluke meter. So the way that you do this is in the milliamp mode, we can measure a certain amount of current, in this case 19 milliamps, and then just switch to the volts DC mode, and we see the burden voltage directly. In this case, it's 6 millivolts and a fraction. I was curious to see whether or not that burden voltage varied with the magnitude of the current, which it does in some multimeters, but turns out in the case of this Fluke meter, it's always about 0.35 millivolts per milliamp. So they have just an internal resistor, which is about 0.35 ohms, which is used as the shunt resistor to measure the current through the Fluke 8842A, regardless of the level of the magnitude of the current. Just to start off here, I'll turn everything off, make sure that we're zeroed. So in the milliamp range, we're zeroed. In the volts DC, we're close to zeroed. If I turn on the power supply and go to milliamp mode, we've got currently 19 milliamps. Let's just take it down to 10 milliamps. So we get some nice round numbers. Here we go. There's 10, and the voltage drop is 3.1 millivolts. So that's about a third of a millivolt drop per millivolt, which is what I was saying before. Yeah, that's what it seems to be. Now, if I come back here and I ramp up the current to, say, 100, there's around 100. And we get just 10 times the burden voltage drop, which is now about 32 millivolts. Dividing by 100, there again you get about a third of a millivolt per milliamp. So they have it in internal shunt resistor. We'll do this again at a higher current again. Take it up to an amp. There's 1 amp. And our burden voltage at 1 amp, 325 millivolts. So there you go. Yeah, it's interesting that there's just one shunt resistor in this Fluke 8842A, regardless of the level of the current flow. It seems it was in auto mode, so as it's switching various ranges, there's no change in the internal shunt resistor. So that's how you can measure your burden voltage, by just connecting these leads and using the volt DC mode. As you're measuring the current, you just switch between the two and it'll report directly its internal burden voltage. All right, thanks for watching.